previous lessons, we learned how to interpret chemical formula in terms of the unit moles, and basic moles is equal to 1 mole of anything is equal to 6.02 times 10 to the 23rd power, right? And we learned how to interpret chemical formula in here. Notice how I have the coefficient here. This is the coefficient, okay? And this coefficient represents how many mole of the substance. And we did this particular problem where I gave you the substance or a specific thing about this chemical formula. And of course, that 3 right there give us 3 moles of this substance, which is Al2CO3 or aluminum carbonate. So we have Al2CO3 with parenthesis 3 right there. And then we go in and dissect the substance relative to 1 mole, okay? So now I focus on 1 moles of this particular chemical formula. In this case, in 1 mole of this, notice no longer we need the coefficient there because the coefficient is 1. How many mole of aluminum we're gonna have? Of course, that 2 right there indicate there are 2 mole of aluminum. And then we get to carbon. Notice how that 3 right there indicate there are 3 of that. So it's 3 times of what inside the parentheses. In this case, carbon, 3 times 1 give us 3 moles of carbon. Oxygen, 3 times 3 give us 9. So this is from 3 times 3. So we have 3 moles of oxygen. How about carbonate ions? So of course, 3 of that. So 3 outside the parentheses give us 3. So this gives us 3 moles of the carbonate ion, which is CO3 2 minus. Right there. We use a caret symbol to indicate the exponent or the charges. For aluminum ions with the charge of 3 plus, it's the same thing as aluminum. So in this case, we have 2 moles of Al caret 3 plus. Okay? Now, why do we need to interpret a chemical formula, especially each mole of a chemical formula, in terms of moles? Well, that is because if you look at your conversion factor, I zoom in here, is that when you have a unit moles of A or B, we can now relate them together if they are in a same chemical formula. And this is known as a mole ratio. Well, think of the word ratio, right? It is the ratio of mole. Now, let's do an example problem so hopefully you can see the values of mole ratio. How many moles of hydrogen are in 3 moles of H3O plus? Now, what is hydrogen? Hydrogen is referring to the hydrogen element on the periodic table. And if we look at this chemical formula, right, how many hydrogen do we have? 3. So 3 moles of hydrogen in 1 mole of H3O plus. So now we have our conversion factors right there. This is our conversion factors, okay? So let's solve this problem. Of course, we are looking for moles of hydrogen, question mark, moles of hydrogen, which we have right here. Always start from your given, which in this case is 3 moles of H3O plus. Okay? And of course, for your end, you have to use a caret symbol to indicate the charge, but not on this video. In this case, we multiply. So for mole A, this is where we're going to start, mole A, and we are going to end in mole B. And notice how we use the letter B now. Notice how we changed from mole A to B. Why do we use letter A and B now? Because now the substance has changed from one substance to another substance. And that's the reason why we have A and B. So if we look at the conversion factor, this would be A and this would be B. It doesn't really matter as long as one letter assigned to another. In this case, we time that conversion factor. We have 3 moles of H equal to 1 mole of H3O plus. And that is all coming from this chemical formula, okay? So now let's solve this problem. So we just rewrite this as a fraction. So 3 moles time. And notice how we have 2 measurements. This is moles of H3O plus. Down here must be moles of H3O plus as well. And exactly how many? Just 1. If this one on the bottom, this one must be on the top. So 3 mole of H. And this cancel out. And this gives us 3 times 3 moles of H. 3 times 3 mole of H. Give us 9 mole of hydrogen atom. There you go. And this is the number. Let's try another problem. How many moles of CO3 2- ions are in 9.1 moles of aluminum carbonate, or Al2 parentheses CO3 parentheses 3? Well, what is CO3? CO3 2- coming from here. So this is CO3 2-, okay? Now, if you notice again, the chemical of the given, right, is in this right here. So this must be our A, and this must be our B, okay? So now, let's go back to the conversion factor. We are starting from right here, and we are ending right there. So we have to multiply by this conversion factor. And this conversion factor is coming from here. In this case, if we look at this right here, this tells us the mole ratios is between carbonate. In this case, how many carbonate do we have? That's 3 moles of carbonate, CO3 2-, equal to 1 moles of Al2 parentheses CO3 parentheses 3, or aluminum carbonate. So 1 moles of, and again, notice how 1 moles of this whole entire substance has 3 moles of CO3 2-. So let's use our stoichiometry flowchart and set up the problem. So again, a given time the conversion factor, which is mole ratio, give us our moles of B. In this case, we have 9.1 mole of aluminum carbonate time a conversion factor, which is this one, 3 moles of CO3 2-. It doesn't matter if I write this first or this first. It's a conversion factor. It doesn't matter. Equal to 1 moles of aluminum carbonate. And again, the conversion factor has 2 measurements, and what determines the one going on the bottom is the previous one, where this one has moles of aluminum carbonate, so the bottom one must be moles of aluminum carbonate as well. And if this is on the bottom, the other part must be on top. And to turn out, it cancels each other out. Give us 9.1 times 3, which in this case is going to equal to 27.3 mole of CO3 2-. And that is our answer. Now let's try another problem. We have how many moles of aluminum are in 3.1 moles of aluminum carbonate. So if we look at this, this is aluminum, okay? And aluminum is right here. So if from here, we can actually find a conversion factor. In this case, it is mole. So first thing first, we had to look at this and say, can I find a ratio, a mole ratio from this particular chemical formula? So of course, there's a 2. So we have 2 moles of aluminum equal to 1 moles of the whole entire thing, right? So we're comparing aluminum to the whole entire thing. So in this case, Al2CO3, 3. Okay? So we have our conversion factor there. And of course, you notice there are 2 different chemicals again. I just assigned the given as the chemical A, and this is going to be chemical B. It doesn't matter. Those are just letters, represent different things. So now let's go back. We have 3.1 mole of aluminum carbonate, Al2CO3. And we time it by the mole ratio conversion factor, just like we did over here, mole A to mole B. Okay? And this is a mole ratio over here. So 2 times moles of aluminum equal to 1 moles of aluminum carbonate. Okay? And now let's rewrite this as a fraction so we can simplify it. And again, this determines what goes on the bottom. This is moles of aluminum carbonate, so down here must be moles of aluminum carbonate from the conversion factor, which is this one right here. So we have 1 mole of aluminum carbonate on the bottom. And this one must be on top. Boom, this cancel out. and we have 3.1 times 2 and give us 6.2 moles of aluminum. And that is our answer right there. Now let's try a more complicated problem where we have a very complicated chemical formula. For example, how many moles of water are in 1.5 moles of copper sulfate pentahydrate? The pentahydrate that is coming from the prefix that represents number 5. So in this case, and for the answer format when you type in the computer, we use a period to represent the dot, which is this one right here. So let's start with this problem. This is our question mark in B, okay? And it's specifically moles of B. And we are given moles of A. So from here, if we look at this, that is the water right there, right? So we know that this whole entire thing, so if I look at this, let me rewrite this again. And here is our water. So we can tell that we have 5 moles of H2O in 1 moles of this whole entire thing. So that is our mole ratio right here. That's relate water and the whole entire chemical formula. So in this case, let's set up this problem. So we have a given 1.5 moles of this copper sulfate pentahydrate, CuSO4, and 5 H2O, times the conversion factor, which is this one right here. That's going from mole A, which in this case is A, and this is B. This B represents this whole entire thing right here. This is B, okay? So we have 5 mole of H2O equal to 1 mole of CuSO4, 5 H2O. And let's rewrite this as a fraction and solve it. And again, this unit in chemicals determine what go here. So in this case, moles of CuSO4, 5 H2O, it must be this one right here. So this one go down there. So we have 1 mole of CuSO4 times 5 mole of water. So if this on the bottom, this must be on the top. So 5 moles of H2O. So again, be careful. This determines what go down here, and the leftover go on top. So this cancel each other out. The whole point we doing that because we want to cancel out the unit and the chemical formula. And 1.5 times 5, that would give us 7.5 mole of H2O. There you go. So in a 1.5 moles of copper sulfate pentahydrate, there's exactly 7.5 moles of water in there. Now let's try the last problem together. How many moles of copper sulfate are in 3.5 moles of copper sulfate pentahydrate? So again, this is that part right there, okay? And from here, we can write a mole ratio. Basically, one whole entire thing, 1 moles of this CuSO4, 5 moles of water. So this is a hydrate, as I mentioned before, okay? This is equal to what? Well, look at this. How many moles of copper sulfate do we have? And of course we know that is only 1 because there's no coefficient there. So in this case, we have 1 mole of CuSO4. And this is our mole ratio that's allowed to find copper sulfate from this right here. So we have our given, we are looking for what? The question mark, mole of CuSO4, okay? And this is what we're looking for. So we're starting with 3.5 mole of CuSO4 times 5 moles of water. And time our mole ratio, which is, again, and again, we're going from mole A to mole B, and that's just one conversion factor, which is the mole ratio. So let's multiply this together. And we have 1 mole, which is this one right here, okay? So 1 mole of CuSO4, 5 H2O. It doesn't matter if I write 1 mole of CuSO4 first, okay? It doesn't matter at all. And that's equal to 1 mole of CuSO4. And let's rewrite this as a fraction so we can simplify and cancel out unit in chemicals. In the process, we have 3.5 mole of CuSO4, 5 H2O, time, okay? And again, this determines what go down here. And this is moles of CuSO4 times 5 moles of water. So this has to be this part right here. Okay? Exactly 1 mole of CuSO4 times 5 moles of H2O. And this is on the bottom. The other part must be on top. So we have 1 mole of CuSO4. And also the mole cancel each other out as well. And give us 3.5 times 1, which is 3.5 mole of CuSO4. And that makes sense because in 1 moles of copper sulfate pentahydrate, there's only 1 mole of CuSO4. And the ratio is 1 to 1. And that's how you use a chemical formula and interpret in terms of moles to get a mole ratio to solve for specific things in that chemical formula.